Okay, team challenge number 1 was a pretty easy one, but it's about getting your skills to apply what you've learned in class to another problem. So in this case, the actual bit that had to do with pH was pretty simple. It was figuring out what the concentration of protons were in a solution given the pH. So that part is pretty easy. We had a pH of 6.8 and we wanted to find what the H plus concentration is simply 10 to the negative 6.8. So that part was really quite simple. We come out with 1.58 times 10 to the minus 7 molar. But I would like you to think about what the number means. So I asked you to calculate how many protons there would be in two very different cell types. And there are two cell types that I spend a lot of time thinking about. One of them is Prochlorococcus, which is one of the smallest marine algae and very important in fixation of CO2 and evolution of oxygen. And the other one is a very large diatom, which is another marine algae which is involved in the same process. So let's look at what we know. We know that the diameter of Prochlorococcus is 0.6 micrometers. That makes the radius 0.3 micrometers, okay? Which is equal to 3 times 10 to the minus 7 meters, all right? So, how do we figure out what the volume of our Prochlorococcus cell is? Well, a coccus cell is spherical, and that makes the volume to be 4/3 pi r cubed. Didn't know that? Google it and look it up. So, that makes our volume to be 4/3 pi 3.0 times 10 to the minus 7 meters cubed. And this gives us a volume in meters cubed of 1.131 times 10 to the minus 19 meters cubed. Well, meters cubed is not a unit that we can work with here, so let's convert that to liters. We know that there are 1,000 liters per meter cubed. Didn't know that? Google it or figure it out. So that gives us 1.131 times 10 to the minus 16 liters. All right, we know our concentration, we know our volume. So if we take this volume and we multiply by the concentration, 1.58 times 10 to the minus 7 moles per liter, our liters cancel out, and we have now something that is 1.787 times 10 to the minus 23rd moles. Well, I didn't ask for how many moles there were, I asked for how many protons there were. So we need to factor in Avogadro's number. There are 6.02 times 10 to the 23rd molecules in a mole. Okay, so we end up with, running out of pen there, 10.8, which is impossible to see. 10.8 as our answer for the number of protons in the cell. So 10 to 11, obviously you can't have an eighth of a proton, protons in the cell at any one time, which is not a lot. Well, what about Coscinodiscus, which is a really big phytoplankton, a really big algae? Well, it was a cylindrical algae, it was described, with a radius of 150 micrometers and a height of 60 micrometers, okay? So, we needed to use a different equation. We're going to use pi r squared h for the volume of a cylinder, which if you put the radius, which is now 1.5 times 10 to the minus 4 meters, and the height of 6 times 10 to the minus 5 meters, you come out with a volume of 4.24 times 10 to the minus 12 meters cubed, or 4.24 times 10 to the minus 9 liters, using the same conversion factor we used here. That gives us our concentration. Oh, sorry, that's our volume. And we have our concentration, which is the same as it was before. It's the same pH. And we end up with 6.7 times 10 to the minus 16 moles times our Avogadro's number. We end up with 4.03 times 10 to the 8th protons. So take home message here. have the guts to try calculations when you can do them, and look what the difference is. You've got 10 protons in this one little cell, and you've got a lot. You've got 80 million protons in this much bigger cell. That's a huge difference.